Okay, hi everyone. Thank you for joining the first Foam AMA, and thank you for everyone who contributed questions. I'm here at our office in the new lab, and I will be starting. So one of the first questions that we have I wanted to address is how will a GPS-based system compare to the decentralized system built with Foam? And this is really a great question because Foam is a solution for blockchains and smart contracts. And because GPS has no proof of authentication or proof of origin, autonomous smart contracts cannot verify and act on this information. So Foam is not necessarily trying to compete with the accuracy of GPS, although it can be possible over time. Our primary goal is to serve autonomous smart contracts with secure localization and verified location data so they can autonomously act on this information. The next question we received is Foam going to be built on the Ethereum blockchain? I can say that Foam is definitely developing exclusively right now on the Ethereum virtual machine. How that actually plays out towards launch will determine what components are on the public chain and which are on designated side chains. We're exploring things like Cosmos zones and plasma pegs for individual areas of coverage so that they can have scalable, high-speed block times, and potentially those would run with different consensus algorithms such as Tendermint. But we are looking that the actual utilization of proof of location and the proofs live on the public Ethereum blockchain. The next question was if we would be dependent on third-party scaling solutions or if we have our own solution. I wouldn't call Plasma or Cosmos a third-party solution, as we would be working closely with those teams and building custom solutions for Foam. The next question there is that if we think it should be the responsibility of dApps to find their own scaling solutions. And I would say yes, we do. At Foam, we are working on a unique problem that needs a unique solution, and that means it also needs a unique scaling solution. So it is the responsibility of projects to make sure that they can not only implement this technology, organize a community around it, but also find a way to allow it to scale responsibly. So the next question we have is what hardware and staking requirements will there be for hosting proof of location nodes? As we've mentioned in our blog post and in some of the chats, right now, Foam is agnostic to which radio it actually uses. Our innovations are focused on time synchronization protocol, which through that you can derive location, as well as the token economics and incentives to actually have the correct incentives to have the system develop. That said, the most interesting radio we're looking at is the LoRa radio, and if you can, we'll be launching our first proof of concept on LoRa. So in that sense, some of the hardware requirements to be what we call zone anchor would be operating a LoRa gateway, and it shouldn't be too much extra hardware beyond what you can kind of get off the shelf already. In terms of staking requirements, you will need a token to participate as a zone anchor or a verifier, checking for fraud proofs. You can think of that token as a virtualized piece of hardware that you need to buy and own in addition to the hardware of running the actual node. And that will be one of the requirements, kind of part of the hardware as well, to be a proof of location node. The next question is, can a zone be made of LoRa nodes that are all in range of a gateway? And does each zone anchor need to be a gateway? So the way that we addressing this are what we call zone authorities are essentially gateways. Those are entities that have access to the internet and therefore can also have access to the blockchain. So they can check the current status of the blockchain and basically be a watcher. So LoRa then also allows for all these kind of subnodes to be attached to one gateway. And those can be kind of distributed hardware in IoT, on Raspberry Pis, out in the field. And those are like the core zone anchors. So a batch of those would have to rely on an authority, and that authority would have access to the blockchain and the internet. So you could have a very lightweight device that is very cheap and register it with a local authority, which you could also own yourself. And then each individual authority, which is a gateway connected to the internet, would have to stay in sync with each other. So that's basically the question of that zones are made up of LoRa gateways as well as the end node devices that don't necessarily have internet connections because they're very low power, lightweight, but they have to rely on the gateway for updates. The next question is there going to be a sign-up list for hosting a zone anchor or beacon? How might people get involved? I think that's a really great question. There's not only going to be a sign-up list, there's going to be ample opportunities for developer grants and access to hackathons and other support from our team, as the only way for Foam to succeed is to actually have people setting up zone anchors and beacons, maintaining them, and becoming their own service provider. So with Foam, we want to empower people to be their own service provider with this proof of location technology. And so, yeah, we will be cultivating a list. Also, in terms of our token distribution event, we want to make sure it's going to people who actually utilize this utility token in our software. So this kind of list will also play into how we distribute the tokens to the initial holders. The next is will there be an incentive system for signing others up to host these beacons in your locale? We are thinking about incentive systems in the actual protocol in the form of block rewards and inflation, in that if you are setting up basically a beacon or a zone anchor, you can get this base reward. There isn't necessarily a incentive for signing others up, but the block reward can be higher on the edge of these zones where there is less activity or less setup, so that you could be incentivized to add new nodes to the edge because you can get a baseline block reward that is higher. So that's one of the incentives we see to encourage growth of the network. So the next question I see is, what are the expected geometries of the gateways and how many to achieve desired accuracy? A desired geometry of the gateways would be a full graph, so meaning every one in the node can connect with each other, but that is desirable and ideal. It won't always work out that way. So there isn't exactly an ideal geometry, but the point is that the deployed network can determine its own geometry without an external source like GPS, so that no matter in which configuration the gateways are deployed, the network can determine its own geometry autonomously and doesn't need to rely on any external information or trust that information. To achieve desired accuracy in a dense urban environment, so for example, with the LoRa gateway, in an urban environment, you could get up to 5 miles of coverage. There haven't been that many field tests in terms of number of gateways for a dense area, so that's going to be one area of active research once we get our first proof of concept and test nets up, trying to actually figure out what kind of coverage can we achieve in dense urban environments, as these low power wide area networks are a very new frontier, so there's very little raw field test information to go off of. The accuracy inclusive of multipath considerations is another question. Yes, that's one of the biggest concerns, but we're able to mitigate that because our nodes are constantly communicating with each other. They're trying to synchronize their clocks, so you can do averaging of the distance of time to account for multipath. And the fact that these constant communication channels are open, and we're relying on the very extreme measure of a Byzantine fault-tolerant time synchronization protocol. The fact is this should try to mitigate for multipath. Of course, if we have more nodes in line of sight, that's another way to mitigate for multipath. The next question is, in what geographic areas do we expect beacons to be rolled out first? I would actually expect in urban areas because this is where you also see a dense concentration of decentralized interest in blockchain technology. There's many meetups in urban areas that are quite large and attract a big crowd. And there's also a lot of big hacker communities in the low power wide area network space. And because we ourselves are based in a big city, New York, and also with people in Berlin, we think that potentially that's the easiest way to kind of build communities on the ground. That's not to say that we are against anyone starting in rural areas, and that would be really exciting if that's also some of the first places people set up zones. The next question is, what are the challenges we might face for implementation? Great question. One might be that a lot of Foam's future depends on also the growth of the entire ecosystem. As I mentioned at the beginning of this broadcast, Foam is a solution for smart contracts and blockchains. So for Foam to be useful, there needs to be a need for smart contracts in the world out there. We kind of project there will be, from everything from IoT to supply chain to even kind of video games like Pokemon Go, to also anything that requires location and a blockchain parameter. So that's one challenge for us, is for Foam to work, the entire ecosystem has to scale, and industries have to actually adopt this technology for there to be a need for secure location verification. Another challenge is just building the actual community and getting people involved, excited, and interested in running nodes at such an early stage. And another challenge is also getting people excited to build their own applications. So it's not only being a validator or contributing computational power, but we're also building many spatial tools here at Foam, not only with proof of location, but also our spatial index web app and cryptospatial coordinate standards. We want to encourage people to build all different kinds of decentralized applications, build with our spatial tools. So those are all challenges of how we can get this to market and build a decentralized ecosystem around these standards that we're proposing. Some of the final questions I see here is about what kind of location on Foam could it be supplemented with other systems like Wi-Fi and GPS? Absolutely, and that's really up to the client side verification, what kind of robust proof they need. If it's a very weak proof required, they could use GPS, but the approach we're taking is that if there's token on the line, if there's money on the line, people can easily spoof things like GPS. So sure, you can use it as a complement to help these systems orient themselves, but really what we're thinking is when there's autonomous contracts that could be releasing funds, there'll be an incentive for people to kind of abuse those complementary systems like GPS. And I see the final question is that Foam will not use LoRaWAN and use a custom protocol. This is addressing that the LoRaWAN MAC layer standard is very limited. It's built for enterprise use cases and only allows one-way communication, so this gateway to the nodes and not vice versa. Where if you just build on the actual radio chip, you can easily do mesh network, ING, and bidirectional communication. The other question is, can Foam devices run with LoRa and Foam at the same time? Yeah, essentially what they would be sending over the LoRa radio signals is signed messages about the Foam protocol. So those are all the questions that I received on our Reddit post. If anyone has any further questions, feel free to try to send them our way. I'm checking now if there are any. I don't see them, but thanks everyone for your questions. We'll have a transcript and recording of this saved up soon, and we'll do another one real soon. So thanks for everyone tuning in.